Okay. All right, and so we're looking at our notes for today, and this is still section 4.3, and we're looking at the relationship between f prime and f double prime. So if we were to draw a graph of f of x here, what does f of x look like? It always looks like a squiggly line, right? Here we go. And we're just going to define some critical values here for f. I don't know, let's call it, let's go ahead and put an extreme value at a, and then another one maybe over here at b, over here, right? And so we have these over here. So if you were to ask you, so what if we wanted to draw, so this is f of x here, or just f, right? So the question becomes, how do we draw a graph? From this one, I want to draw a graph of f prime. So how would I do that? Well, if you remember, f prime is just the slope of the function, right? So how do I make a graph of the slope of the function? I don't know. Well, I have to just determine what's going down with this one. So I have to figure out the slope of this one. So if you notice here, f is increasing. So this here, f prime, is greater than 0. Okay? And we all know this already, but this is just a reminder. Here, I have a horizontal tangent line, f prime is equal to 0. Here, f prime is decreasing, which implies, f is decreasing, not f prime. F is decreasing, which implies f prime is less than 0. Here I have a horizontal tangent line, which means f prime is 0. And here f is increasing. Increasing means f prime is greater than 0. Okay? So notice, this is the graph here of f. Okay? Let me just, f of x. Okay? So all of the values here are f. Okay? Here, f is greater than 0. Here, f is less than 0. So now we're going to draw the graph of f prime. F prime now. Okay? So now for f prime, here, if you agree, this is the graph of f prime, not f. So here, above the x-axis, f prime is greater than 0. True? And below, f prime is less than 0. So all we have to do is figure out what's going on here. So we know what's happening here. So if we look at the original graph, f prime is greater than 0 from negative infinity to a. So if we call this point about a here, all we know is that f prime is doing what? It is increasing, so f is increasing from negative infinity to a, which means it's above, right? So what does this mean about f prime? F prime is over here. It is above the x-axis from negative infinity to a. Okay? So it is actually above here. So this graph is somewhere above like this here. Why? Because f prime is greater than 0 from negative infinity to a, so it's above from negative infinity to a. Okay? If you notice here, what happens, f prime is 0 at a, so that means the height is 0, i.e., it goes through the x-axis here, f prime. F prime. Now, some people might ask, could it have gone this way? Sure, that's fine. Okay, we don't know the concavity of the function. Next, over here, f prime is less than 0 from from a to b, right? It's decreasing. So that means it's below the x-axis from a to b. So what is it doing? I don't know. Maybe it's like this here, right? Oh, but I messed up. Why? Because at b, what is f prime? Which means it needs to be at, so this needs to come back up here. See? Because see here how f prime is less than 0? So it's down here, right? And then f prime is greater than 0 from where? B to infinity. So from b to infinity, it's greater than 0, which means it's above. So this piece is just going to go above here, and it looks something like this here, maybe. Okay? So far, when we graph these here, all we know, we don't know the exact curve, but we know it's going to look something like this. So you could have also graphed f prime like this. You could have done maybe something, could it also look like this? Yes, this is a reasonable sketch of f prime here. Okay? We're going to graph f double prime right now.